Welcome to Navigating Computer Science and BPS Tech Talk. I'm Rashmi.
I'm Nick.
And I'm Haruna.
The purpose of this Tech Talk is to introduce teachers, administrators, parents, students, and other stakeholders to various tools and methods for teaching CS in BPS. We hope to answer questions related to cost, platforms, usage, and specific suitability for your students and school.
But before we go any further, we'd like to talk about some of the myths about coding, and we'd like to debunk some of them for you.
First myth is that coding is only for older kids. And that is absolutely not true. There are activities that you can start even in pre-K that will give students a basic understanding of coding principles that will help them out later on in school.
Absolutely. Second myth is only programmers need to know how to code. Really? Our kids can code. Coding is expanded from K to 12 spectrum, and we want our kids to really start looking at computational thinking and think like scientists and programmers.
The third myth is real coding is text-based coding. That's not necessarily true. There's a lot of block coding that's available, block coding platforms that are available to students from K through 8 and from in high school as well.
And those skills that you learn in block coding translates right over to text-based coding, which comes later on in high school and beyond. And that kind of leads into our next myth that teaching coding is useless because coding languages are always changing and the things that you learn now are going to be outdated by the time students go to college. It's true that it might be outdated, but the concepts that you learn now through coding in block or in text will translate right over to those new languages. So what you teach is not going to be useless or obsolete.
Absolutely. The fourth coding myth is I won't teach coding because I don't know what programming language to teach. As Haruna and Nick mentioned, there is a spectrum of languages, block-based coding, text-based coding that we look at when we are teaching computational thinking across grades. And you can start with robotics, you can start with Lego kits where students are kinesthetically working with their hands and learning the algorithms, and then they can translate into coding.
And the last myth we'd like to talk about is the myth that you need to have a background in computer science in order to teach coding. Nothing could be further from the truth. There are lots of teachers, myriads of teachers who do not have a background in computer science or STEM that are actually teaching coding now in schools from K through 12.
So why teach coding in schools? It's a new concept to be teaching coding in schools. Actually, it's not really a new concept. I learned it back in school in the 80s when I was in junior high. It's kind of making a comeback right now. Because there's a recognition that computational thinking is a fundamental problem-solving skill that benefits students in all areas of life.
It's also the logistics and the data around it state that more jobs are projected to require computational thinking and coding skills in future because we really do not know what's coming in the future for our kids. So it's sort of building that repertoire of computational thinking, critical thinking skills into their education, and computer science allows for that to happen.
And many of the parents are aware of this, and so there's been surveys done, and the surveys showed that 90% of parents want CS to be actually taught in schools. So with this new need for computer science within schools, Massachusetts is currently formulating its digital literacy and computer science standards. And their vision is meaningful participation in modern society requires fluency in the uses and impact of technology for living, learning, and working. People need to be able to apply knowledge, skills, and dispositions central to digital literacy and computer science to their chosen interests and career fields. They must become computational thinkers so they can create, apply, and change existing computer hardware, software, and devices to meet the computing and information needs of their life and work.
And in this new standards, Massachusetts always had a digital literacy standard, but now they merged it with computer science, and there is a new strand in there called computational thinking, which really encompasses all the computer science piece of digital literacy and computer science standards. Okay, so if you are going to adopt computer science in your school, there are several factors that you should be considering. One of it is the tool age appropriate. Obviously, it goes from K to 12. There are different tools available at different age levels.
Mm-hmm. The second factor to consider is what are the curriculum needs for your school? Do you want a standalone CS course or do you want to integrate it into other subjects? We highly recommend integration across other subjects as well because that gives students access to computer science in many different fields. One of the factors to think about is do you want to do it during school hours or do you have some after school time, programming time during which you can offer computer science offerings?
Another thing you have to consider is the technologies that you currently have available. Many of the schools can actually teach computer science right now with the things that they have already, for example, Chromebooks or Macs and whatnot, or tablets or mobile devices. And you'll have to be aware with that, if you find that you do need more technology or more devices, you have to consider the costs and what you're willing to spend on the program or the lessons or curriculum that go along with it.
And slightly related to that, the other question you should be asking is, do you want to do software only or software and hardware? So that means, do you want to be coding on the computer, creating some kind of computer artifact like an app? Or would you like to include hardware in it, which takes you more into things like robotics? So in this graphic, the horizontal axis is the grade levels. So on the left side of the graphic, you will see the younger grades, and then it progresses through elementary, middle, and then high school. And then on the vertical axis are the cost. Bottom half are the free apps and free tools available, and the top half are the ones with price tag on them. They get more expensive as you go up on the graph. And as you can see, the higher up you go on the chart, you have more hardware associated with it. The bottom half is mostly just software. So when you're doing computer science in K through 12, there is sort of a progression of skills and tools that you will be following. And at the beginning, for pre-K and very early elementary, you'll be starting with pre-programming skills, which means basically you'll be working not necessarily with computers, but more with sequencing skills and just skills that will have students practicing giving instructions, very specific instructions in order for something to happen.
And then next you go to block programming, which is essentially syntax or text programming, but chunked into blocks that you can easily place next to each other on top of each other. These blocks act as groups and different functions for computer programming, and it's used primarily for elementary and after into middle and high.
Then we go into the text programming aspect of it, which will have a syntax, which is the way you write the code. And there is a concept of compiler, which basically the code goes to the computer and computer understands it and runs it. And then there is an output. That's your compiler. So that's what's required in order to run a text-based language. There are obviously object-oriented languages with text-based languages, and there are some languages that work on web. So again, the progression really allows you to see where your students are and meet them where they are.
Okay, so for the youngest of the students, for pre-K through grade 2, there are different apps available, and actually most of these apps are on tablets such as iPads or Android, but there are some of them available for Chromebooks and web-based as well. And those are Codable, Daisy the Dinosaur, the Foos, Tinker. There are other ones out there. There are new ones coming out all the time. Some of them do come with curriculum such as Codable. But for Codable, there is a free option, and then there is an advanced option with more curriculum if you pay. So there are different levels of service available for each of them as well. The one characteristic about these K through 2 apps is that they are for pre-reading students. So they're specifically made for students who don't yet read, and they're very much block-based, and they come with a lot of very basic applications to teach pre-coding skills. One of them that I do want to highlight is Scratch Junior, which is, again, it's an app that works on iPad, Android, and Chromebooks now. Scratch Junior was a spin-off from Scratch, which is a very popular programming code used in upper grades that we'll talk about later. But this was a spin-off specifically for pre-reading students, and it comes in two flavors, the original one and the PVS version that has all the PVS characters in it. And it has a curriculum that ties really nicely into ELA to make interactive stories. And for the hardware side, for pre-K to 2, we have the B-bots, which are popular in a lot of BPS schools to teach kids sequencing and pre-coding skills. And there is the Kibo Robotics by KinderLab, which gets a little bit more into coding. They get into repeat loops and things like that as well. Which is a robot with wooden blocks that you can connect together to actually make a code. And the nice thing about B-bots and Kibos is that you don't need any other technology. You don't need a computer, you don't need a tablet. Everything is right there in the box.
In addition to that, we have little bits, which are easy to use electronic building blocks that empower students to build, invent anything from your own maybe remote control block or like a home device. And you can also do some programming with their new STEMS kit. Students get used to the electronic gadgetry and sort of delve deeper into the programming. There is also Little Bits Gadgets and Gizmo Bit, which allows them to play a little bit more with certain sort of making the games or gadgets. There is a synth kit, which allows them to work with music. So there is a art component to it that is being embedded with the Little Bits. Code.org or Code Studio has really great online courses for students that allows them to go at their own pace and discover computer science through these courses. So they have a course 1, which is meant for early readers, which is also from age 4 to 6, and is recommended for grades K1. This course combines integrating CS Unplugged activities with some computer programming, and the students are able to make some games, a story that then they can share. Course 2 focuses more on students who can read but have absolutely no prior programming experience. It is recommended for grades 2 to 5 and sort of ages 6 to 12.
Course 3 takes you a little bit further into programming, and actually course 3 and 4 are both for slightly older kids. And the nice thing about course 3 and 4 is you can switch back and forth between JavaScript and the block coding to take you a little bit more deeper into the real world of coding. And then there is a App Lab JavaScript for high school students, which is another online course that students can take to actually do more JavaScript coding. So Code Studio really takes you through the entire spectrum from K to 12. And I think some of you have used the Code Studio or Code.org tutorials for Hour of Code that you may be familiar with. And it's almost like an extension to that.
That's right.
This brings us to Scratch and Store Logo. And as you had seen on the graphic, it sort of extends from elementary onto high school, and you see the scope of this really great block-based programming. Both Scratch and Star Logo, and there are many out there, which are block-based programming languages. They can be used between K2 to 12. They use free web interface. And can be used across different platforms, computers or Chromebooks, which is really great because BPS has a lot of Chromebooks in classrooms, and this allows them to use those Chromebooks to teach computer science.
And these activities can also be integrated into the class by single activities or can be used as a curriculum. There are different curriculum options available for both of those programs.
Right, and again, you can use Scratch across the different content areas as well. You can use it, you don't have to use it just for computer science. You can use it to design in different, across, again, all content areas.
Absolutely. Next is a tool called Sketchpad or Sketch.io. The online version of this tool is free, which is called Sketch.io. Sketchpad is world's leading mathematical dynamic visualization software, which is used to teach, illustrate, and illuminate computational thinking concepts in a more tangible visual way. Which in turn sort of promotes the higher understanding and hence engagement in students. Sketchpad comes with a pro version, which is again you have to pay for, but Sketch.io is the free version. There is a Sketchpad at 3.7 version, which is free, and it's all online. So again, it is across all platforms, and you can implement this across grade K to 12. Again, our recommendation is starting from K2 because then students are reading concepts. They're past the early readers level, so then they can interact more with the software. Python is a free object-oriented language that's available online, and you can compile it online, so it's platform independent. Django, the popular open source web application framework, which is used across an Instagram and many other applications, is written in Python. So you know the scope of Python in general. It is simpler than C++ and Java just in terms of its syntax. So the recommendation from College Board is that you start introducing it at middle school levels. And it is very simple to compile, and sort of the scope of Python is increasing because of its friendly nature in terms of just the syntax and how it is formatted. The compilation errors are that much lower, and there is much interactive curriculum available for Python that is integrated across subject areas. So we highly recommend this language, and it is highly used across grades from 5 to 12, but we say sort of present it to your students when they are ready for it.
So Hopscotch is a block-based language, and it's available on iPads and iPhones, and it's used primarily for grades 5 through 8. It has its own curriculum, and it's free. And you can learn CS through designing games and different apps.
And the nice thing about Hopscotch is you can easily share the game with your friends. So once you make a nice looking game, you can share it with your friend and play each other's game, which is really fun.
Yes.
And now we're going to move on to some hardware, which obviously comes with some cost associated with it. The first one is Makey, which is it's actually not really a programmable device. It's just a keyboard device, which kind of simulates you pushing a key on a keyboard, but it connects the physical world to a program. So instead of just pushing a key on your computer, you can create buttons in the physical world to work with your computer. And a lot of people will program Makey with something like Scratch or some other language so that you can have the program interact with the outside world and the physical material like Play-Doh or food or whatnot. There are also a bunch of programmable robots out there. There are new ones coming out all the time. Some of the more popular ones are called Sphero or Dash and Dot. And these robots are made specifically to teach students coding, and not necessarily they're not robots to actually like do something or for you to build. They are pre-built robots that you give commands and they will move around and you can learn coding that way. Most of them work on tablets and computers. Most of them will use Bluetooth connections, so you will need some sort of technology to control them. And then we have Robotics Kits that actually lets you build something. The most famous ones are Lego Robotics Kits. They come in different flavors. For the elementary school, grades 3 and up, we have the Lego WeDo Kits, which work on computers, Mac, or PC, tablets, and also projected to work for Chromebooks in September of 2016. And they come with nice, very STEM-oriented curriculum for you to use with your students. And then for higher grades, upper elementary, middle, and high, we have the Lego Mindstorm Kits, which are, the newest ones are called EV3s. And they come with a bunch of sensors, motors, and you can create your robot and program them. And there are also other robotics platforms as well, such as Vex. And all of them will require you to have a Mac or PC. They do not work on Chromebooks.
There are a lot of text-based programming languages that are currently being used in BPS and across. Here is a quick sampling of what are some of the popular languages that are out there that we highly recommend learning. So part of it is, we talked a little bit about Python previously. Java is one of the most used language today. It is almost 90% of the Fortune 500 companies use it, so it's a great language to know. It is free. It is highly portable. It also is platform independent, which means you can use it in Macs or PCs. We'll talk a little bit about compilers, but there is a Java virtual machine which allows you to compile Java across platforms. It is definitely more friendly than C++, which is more verbose, but Java is also very strict in terms of how you write it and how it's going to compile. So little mistakes in terms of syntax can cause your Java code to break down. That's why it is important to sort of have a very structured way of learning Java, and we'll talk about some courses that offer you that opportunity. There is, of course, C++, which is one of the most used object-oriented programming language. We talked about Python, which is, again, much simpler than learning Java and C++, just in terms of the way it's structured, the syntax, the ease of use. A lot of companies, including Google, use Python in their code. And you have Raspberry Pi, which uses Python integrated into it to code.
So Ruby also is an up-and-coming language. It's an object-oriented language, and it's used on many of the famous websites like Twitter, Airbnb, and even Code Academy uses Ruby.
So this sort of gives you an overall perspective of what languages you should be learning. And if you're learning C, which is a procedural language, that's a great start as well, because that leads you into the object-oriented programming of Java or Python and so on and so forth. Also this JavaScript, which is a web development language and allows you to interact with web. We also wanted to talk about processing, which is free across all platforms. Flexible software sketchbook, it's a language which is used in visual arts to code within context of visual arts. So since 2001, processing has been promoted quite a bit in online communities, and it also allows you to interact with the software from a code perspective, but also from a visual, interaction perspective. And it's also quoted as one of the highest online communities that's growing in terms of student interaction, teacher interaction, and of course other stakeholders.
Next, we're going to start talking a little bit about programmable microcomputers. Now, programmable microcomputers are small, low-cost programmable computers, such as the famous Arduino. You also have Raspberry Pis, and you also have Edisons as well. There are many other types, but these are some of the more popular ones that are coming into play right now. With these microcomputers, you could teach basic hardware components and basic programming using Python, using Java, and it's a really great way to essentially build your own computer. Most require computers to program them as well, though. So what you'll have is essentially you'll have the microcomputer and you'll be programming them through another computer. So most microcomputers require a PC or a Mac. Next, we're going to get a little bit into web development and some of the languages that are associated with web development. And this is mostly associated from grades 6 through 12, so middle school and high school. The two main languages that are used to make websites and to make web pages are HTML, which is hypertext modeling language, and CSS, cascading style sheets. So you use those to design media and again to design sites on the web. And it allows you a knowledge of these languages allows you to essentially navigate a website, make one, and not only make one, but see other websites and see the coding behind that as well, and implement some of the strategies that other websites have used on their with their HTML into yours, and being able to see what's been going on the back end of other websites.
And absolutely to that end, we also have, as we mentioned, JavaScript that goes into web development, and a little bit of action scripting, which is another programming language that allows you to have some animations and graphics onto the web development section. Obviously, as Nick mentioned, we have WordPress and Google Sites, which are template-based, sort of lets you interact with a web and then see the HTML at the back end. So that's a great way of learning web development as well.
Web development is a great way to incorporate coding into any subject area. So for example, instead of having a student write a report on a history topic, you could have them put together a website, which is now open for the world to see. And it increases the relevancy, and you can also have other people view it, comment on it, and interact with it. So it's really a wonderful way to integrate it into any subject area.
And again, like Haruna said, essentially you're able to take away the walls of the classroom. You're able to really start collaborating and you start to show stuff that goes beyond just your classroom and even your school and lets you put things out into the world. Next, we'd like to talk a little bit about creating apps for mobile devices, and one of the main ways that middle schools and high schools have been doing this is through the use of MIT App Inventor. Now, MIT App Inventor is a block coding platform, and it's for making apps, and it's used primarily with Android tablets and phones. And so the great thing about it is it's block language, so it's not easy to learn, but it's more on the basic side. But eventually, what students can do is they can start with the block language and can go into linear language, and what students can do is actually create and formulate their own apps using it.
And for high school students who are more independent learners, there are lots of online platforms that they could use to learn or teach themselves how to code. And Khan Academy, Code Academy are just two examples. And in each of them, there are various coding courses on there, pretty much one for each programming language. And this is really a great way for students to learn. And maybe if you have an after-school club, you could take advantage of these online curriculums that are out there. Or you could also teach it in your class in the sort of flipped classroom model and incorporate some of these online curriculum tools into your classroom.
Which also brings us to some of the teacher-led online curriculums that are out there. You can obviously mix and match these curriculums, or you can use them as standalone curriculums. Exploring Computer Science is one of the curriculums that's sort of a grant from NSF. It was developed under their guidance. It's a really great curriculum. It has 6 units, approximately 6 weeks each, and the course was sort of developed to broaden the scope of computer science. So it includes different programming aspects, block-based programming, and then sort of takes you a little bit towards text-based programming. The second course that we recommend, it's in the K5 spectrum, which is CS Fundamentals, again introducing students in the K5 spectrum to concepts of computing, algorithm writing, what are variables, what are loops, things like that. And then there is a CS Discoveries curriculum, which is actually the newest curriculum in development. It will be available in 2016-17, and it sort of fits right in between the CS Fundamentals course and the CS Principles course, which we'll talk about a little bit later. It's a nice, engaging curriculum that allows students to create artifacts and engage with CS as a medium of creativity, communication, problem solving, and overall fun. The AP Computer Science College Board curriculums, which are obviously the first one is AP Computer Science Principles, which will be released in 2016-17. It definitely encourages broad participation. It is language independent, which means the teacher can choose the language of choice, may it be Python, it could be Scratch, it could be JavaScript, or we highly recommend not using Java with this, but it's sort of the principles curriculum again covers the engaging aspects of computer science and engages students in the creativity of computer science. Then comes the AP Computer Science A course, which is the equivalent of a first semester college level course in computer science. The course emphasizes object-oriented language, is Java dependent, so you have to do all the coding in Java. Obviously, you appear for the test with College Board, and you, based on your grades, you can actually get CS1 college credit for it. You do need 2 years of mathematics and some programming experience to take AP Computer Science A, and we have, I think, 3 to 4 schools in BPS who are currently doing this. So there is a community of teachers who are sort of engaged in the AP Computer Science A course, and we can collaborate together.
And it's growing too as well.
Absolutely.
Thanks for tuning in to our Navigating Computer Science BPS Tech Talk. We will be offering ongoing year-round professional developments, and you can also tune in to our Digital Learning Team YouTube channel. Thank you for watching. I'm Nick.
Rashmi.
And Haruna from the OIIT Digital Learning Team.